All right, so we're gonna convert a 2D image into a 3D image. So I just did a Google search, and then under search tools, I want it to be black and white image. And so I'm gonna take this one, and we're going to just save this image to my computer. All right, so I'm gonna save that into downloads. And so what you want now is a PNG to SVG. So what you have to do is you have to convert it into an SVG file to import it into Tinkercad where you can edit it. So this program of onlineconvert.com works out pretty well. And I think we can do almost any convert image. All right, so let's try this one here of, yep. All right, so I'm going to upload that image that we just downloaded now. Downloads. All right, and just gonna tell it to go ahead and convert it. And so this is gonna give me a SVG file, and that's something that then Tinkercad can take and turn into a 3D model, and then we can kind of experiment with what, do what we want with that model. All right, so it's saved right there to my computer. So I'm gonna head over to Tinkercad. I don't know what beta design is. Looks exciting. All right, we're just gonna create a new design. And so in Tinkercad, this is where you can create your 3D models. And they've got a lot of general shapes, like your building blocks, your geometric ones. And we're going to import that SVG file.
So if you don't import a file, you can use some of their basic
right, yeah.
stuff right there.
Yep, yeah, and you can do a lot with it. All right, so I'm just going to open up the SVG. I'm going to click import. And so the place is too big, so we're just going to shrink it down here. So I'm going to change it to 40. And we'll kind of render here a little bit. Whoa, that is a huge molecule. All right, and so now, so here's our molecule. So this was just our 2D image that we had before. And, oh no, here it was. Yeah, so this was our 2D black and white image. And it's got to be black and white so that it can kind of figure out what it should do. So basically, if that, like anything that's white on the screen is going to be kind of a hole, or like, not be a object in the 3D model. And anything that's white is going to be. So I'm going to zoom in on that. So this is our 3D model right now. And so if we want to, we can go ahead and like rotate around this. We can expand this now too. So if I want this to be taller, I'm going to click on this little grid right there. I can expand this. And let's say now if I wanted to add in a little plaque that goes behind it, I'm going to scroll down to, I'm going to bring in one of the boxes. So I'm going to take this, I'm going to expand it over that, and I want to have it so it's not as tall. And there we go. And so now we now have our molecule as this little tiny like plaque that we could print out then. And so there's a number of different things we could do with this. We could combine this with other things. We can make a molecule from this as well. So we could drag in different spheres and then represent the same thing then with spheres. So then students could then learn how it is that the, this Lewis diagram, no, it wouldn't be a Lewis diagram, about how this diagram is similar to the molecule. We could even like type out the whole thing.
Does it have to have a plaque, or can it be free floating?
It could be free floating. It
That wouldn't be a plaque though, because the H and the O are not connected.
Right.
Or are they?
Yeah, right, yeah, so they're not connected and it's not connected to the line. So when you print it out, it'd be a bunch of separate things.
Separate things that you could set. You
put
could
it
set them
together.
all.
Yeah, you could put the stick figure out and then, okay, here's the elements.
Right,
Put it
and you have to put it in the right shape.
Yeah, and that's where you can get really creative of how you'd want these things to kind of fit together. And you can have it, you can kind of experiment with, instead of like having it printing like on top of it, I'm going to have it instead cut this object out of it. So I'm going to move this up a little bit by clicking on that arrow. And I'm going to turn this into a hole now. And so now, when I select that base and this, and I group these, it's now actually just going to cut that out. And so now it's going to have these holes inside there now. So now basically it's kind of like it's been etched into that design on there instead. So you can do some really fun stuff with that.
Can you show me how you do that? I was
was trying to.
Yeah. So it's the everything in Tinkercad. What's nice is that it can either be either it's a solid object or it's a hole. So right now I've switched it back to, and I can change the color, but that doesn't mean anything when we print it. So it can be a solid object there, or it can be a hole. And what happens is that when you group objects together, anything that's a solid and a hole, it'll basically cut out anything that's set up as a hole from the other objects. Now when I group it, it's now going to cut those out.
Can you adjust the depth of the hole?
Yep.
It could be push versus cut through.
Right. If I double click on it, I can kind of then go in and then start to play around with this. So if I want to have it so it doesn't go as far down, I'm going to click on this little arrow up there and then raise this up so it doesn't go in as far. And now I click off to the side. It'll go through and render it again, and it'll chop out that hole. Yeah, so now it's not as deep as it was before. And that's where, with Tinkercad, so you can kind of now experiment with that. You can add in additional shapes in there. And what's nice too is that you could take like a template of this and then give students this template, and then they're meant to experiment with that template. So you can kind of like set up like different building blocks. So if you want to build an atom, then you could have the building blocks set up for them, and then they rearrange those to build the atom, and then they export that. So when you're all done, what you then do is just download for 3D printing in .stl, and then that's what you put into your 3D printer, and then it'll print it. But then also if you want to, you can, so we're just going to save this, and then if you want to share this out with students, you go to properties, and we're going to make this be a public file. And then you would just copy this link and share that link with your students, and they could then view it and make their own copy of the model.
Once they make a copy, they can.
And then it's theirs. Yep. And then they can go through and they can edit it. And so to show you some examples here, like, so I'm just going to search for like molecules. So other teachers have actually created a number of different example projects. And here's different molecules that people have made.
Right side circles.
This one right here.
Is there a way to, I don't remember how you specify like specific dimensions. I know you can grow and shrink.
Yeah.
But you can type in like what like an actual measurement is on those as well, right?
I don't think so in Tinkercad.
No, I thought you could tell it like how many centimeters you wanted it to be.
I don't think so.
I don't. It's been I used it briefly like before Autodesk took over. So.
With some of them, where they've got these shape generators, some of those do allow you to type in specific measurements. I don't think so for this one, unless there's something that I'm.
Yeah.
Yeah. So here you can then click and then resize, and so you get you
type into that number there and see if you can that 121. You type into that 121.
I don't think so. Yeah, I don't think you can. That is one of the things that would be nice. Yeah. Yeah, you can shrink and grow it. And it's got this little snap to grid helpers right there. So you could then shrink it down to, so if you want to get more precise, or you could just turn it off all the way. Having it go by 1 millimeter is really nice. It's also a really good way of students having to learn metric.
Yeah.
When they print something off and it turns out to be really tiny or like gigantic, it's like, oh, that's what a millimeter is.
Can we use this with our legislators? So
Then they'll legislate that Tinkercad must use inches. Because you can switch it to inches, but then it just becomes a big, huge mess, and it's super.
Yeah.
And it's even funnier then because then students get really confused when they're trying to resize things and like trying to figure out, because then it does fractions of an inch, and then they quickly learn why inches suck.
How expensive like is the ink, like the plastic? Is it?
Yeah,
The-
you have to replace
are you
all
still
that.
Yeah.
screenshotting?
Yeah.
They come out building this huge thing and then